Good morning, everyone. I'm Stephanie, and today I'm going to talk about the flow pattern north of Taiwan and the migration of the closure. The northern shelf of Taiwan is a highly dynamic oceanic region. The closure current flows along the Taiwan's east coast and frequently intrude onto the shelf. And the water from the Taiwan Strait usually go north, but the water would go interact with the closure intrusion. The seasonal migration of the closure, we can see in fall and winter, the closure gets closer to the shelf, and sometimes even moving onto the shelf. And in spring and summer, the closure migrates offshore, forming a different flow pattern. The Taiwan Strait outflow usually go north in winter, but when the northeasterly monsoons intensify for days, the southern flows occurs. And in this figure, we can see the closure was split into eastward way and northwestward way. And there's a counterclockwise circulation located southwest of the branch. The subsurface closure water was intrude onto the northern shelf through this circulation. And in this study, we aim to know the seasonal variation of mesoscale flow patterns north of Taiwan and their relation to the migrations of the closure. And also the interaction between the intruding closure and the Taiwan Strait outflow. To investigate this pattern, we analyze the historical oceanographic data from Ocean Data Bank. And this data set includes shipboard ADCP for current velocity and hydrographic data. And we also collect mooring data. The data is from July 1992 to March 1994, and it's located on the eastern side of North Mianhua Canyon. In this mooring, there's two important instruments: the ADCP for current velocity and the CDD for salinity, temperature, and depth. Additionally, we also have 3 shipboard ADCP data from 3 research cruises. The cruise A is conducted in summer, and cruises B and C were conducted in winters. And these 3 pictures are their cruise passes. So because we mentioned the closure would have seasonal migrations, so this migration may also influence the flow pattern north of Taiwan. So let's look what happened north of Taiwan. In the summer, the cold zone, as we mentioned, there are two a mainstream of the closure and a branch of the closure. It will separate into 2 parts, and a cold zone will occur in summer, and it's located not really steadily. Like this is more easterly, yes, and the Taiwan Strait outflow was blocked by this cold zone. Like here, we can see the outflow of Taiwan Strait cannot go to go through this place. Yeah. And in winter, the water from Taiwan Strait joins with the closure. Let's see here. Like the outflow go through here and go northward. and creating a strong northward flow, like this. So, like we mentioned before, the counterclockwise would move eastward or westward. So why we want to wonder what happened in this situation. So we use a time series data. So this axis is about time, and this is y-axis is about depth. The counter is east-west velocity. As we can see, upper 100 meters, the velocity usually go eastward, but in under the 100 meter, we can see this. This means go westward. It's not about along the winter, along the seasons. So we can see under 100 meters, there's obviously intra-seasonal migrations. And this confirms that the closure does not follow a steady seasonal patterns. So we use temperature, salinity, and U vector, which means east-west velocity at 190 meters over time. So this axis is also time, and this temperature, salinity, and U vector. And we can see the temperature, salinity have similar fluctuation with U vector. And when the closure moves eastward, water becomes warm and salty. Otherwise, when the closure moves eastward, the temperature and salinity decrease. So this it also confirms the intra-season variation. So like we mentioned before, the counterclockwise circulation will move, and here the counterclockwise circulation even gone. So, the absence could be related to its own intra-season migration. So let's summarize the flow pattern north of Taiwan. In the summer, the closure moves offshore and splits into an eastward flow and a northwestward flow. A counterclockwise circulation can and a cordon could be found here. And the Taiwan Strait outflow is blocked by the counterclockwise circulation. We can see here. And in winter, the closure shifts closer to the shelf and maintains its strong northward. Yeah, we can see here the northward flow. And the Taiwan Strait outflow joins the closure, like here, and go northward. So there's three key takeaways from this study. First, the closure migration significantly impacts mesoscale flow patterns north of Taiwan. Second, the cordon is a key feature of summer circulation. Third, the Taiwan Strait outflow has secondary influences compared to the closure. So thank you for your listening.
I want to know what is the importance of the closure migration to Taiwan.
The closure migration will caused by like global climate change or the whole circulation of the current. So if the closure migrates abnormally, yes, so maybe can change the global climate, and also the fisheries. Closure brings fish to Taiwan, and yes, and so if the closure migrates abnormally, maybe we can get the fisheries. Yeah, something like this.
Okay, thank you.
Can you go back to page 3 and explain again, because I can't clearly understand what do you mean.
We know the closed shell is go through this way, right? So when the closed shell go to here, it will blocked by a steep continental shelf break here, like here. They don't mark the steep continental shelf break on this figure, but maybe like here. So the coral shell will block split to two parts. Like this is mainstream and go eastward, and this is the branch flow go northwestward. And this branch will bring closed shell, warm and salty water to the East China Sea. And here will appears sometimes will appears as codon, which is counterclockwise circulation. And this circulation is a feature of summer. And this will bring subsurface glacial water to intrude onto the North Shelf of Taiwan.
Thank you.
Thank you.
Can you explain this graph again?
This figure is want to confirm the intra-season migrations. So like upper 100 meters, we can't see any like seasonal or intra-seasonal migration. It usually go eastward. The flow go eastward. And however, under the 100 meters, we can see here, like in summer, it usually be found the westward flows. Yeah, it's abnormally because the closed shell usually, like we mentioned before, the closed shell usually go is westward, right? But it go the opposite direction, so it's not very normal. So this they confirm that is intra-season migration happen here. Yeah.
Does the cold dome phenomenon cause any impact on the environment?
I mentioned that the cold dome can bring subsurface closed shell water to the north shelf of Taiwan. So maybe it can bring warm and salty water to influence the whole flow pattern north of Taiwan. But what will happen in this study? They don't mention it. Yeah.
Thank you.
So this paper is relatively easy to, in terms of physical oceanographic paper, it's a relatively easy paper, and she did a good job because she has this nice talk speed, and her slides were easy to read, and very often she concluded her slides. I think also like this one. There's a concluding sentence somewhere. Okay, so these all makes her. And the fonts are large enough, so this makes her slides easy to follow, and also her the oral part was also easy to follow. But of course, there are places to improve. Okay, so at the beginning you didn't use the mouse very often, but later you use it. So remember to use it. Okay, because you were talking about spatial patterns. So very often you shouldn't do this. Okay, you should do this. Okay, and then what confused me was in your introduction slides where you talk about, because you want to talk about flow path of the migration of crucial. And I didn't really read the full paper, but my feeling was like in your introduction, you told us the conclusion already. So that was a little bit confusing. And I think especially, I think this one, isn't it result figure? No?
It's the same author past studies.
A past study. Okay, it looks a little bit like the result, so it was confusing. So actually, I would recommend that because it's a little bit like you already tell us the conclusion. It's really a little bit weird. So I would suggest that instead of telling us, this migrate this way, that way, it would be great to following their question. First, you tell us the importance of crucial, okay, and then you can also tell us that it has been known from previous study that there's a codon here. But to my understanding, I think if I understand the paper correctly, it is not sure whether the codon is there for the whole year, or is it for a specific season? Okay, so maybe you can tell us how persistent is this codon, and also follow their question. You can tell us why is this codon important for us. So you need to tell us more about the importance of this study. And then you mentioned you just mentioned the quality, like a temperature salinity of the codon. But I think you should know the importance of upwelling, right?
Oh yeah.
Yeah. So it is. You mentioned something regarding fishery, so you are missing a keyword. Why is this important for fishery? Okay. And then here you said a lot about here about this Taiwan Strait outflow, but I didn't see any keywords printed. Okay, you should print Taiwan Strait outflow. Okay. And yeah, like I said, it is a little bit confusing. So it would be great to clearly split what has been known from what will be done, because when I see the introduction and I see this, I was really thinking, okay, what is new? And this is okay, this is okay. As I mentioned many times, although you might think this is so basic, but because this is a talk to a general public, sort of, it would be really great if you can show some photos of the instruments you're talking about. And here you mentioned all about these oceanographic data, but here actually you are not using data from any of these you mentioned. It's actually satellite data, and you did not explain the satellite data, like what this color bar mean. So you should explain it, okay? And then I would say, if I were you, I would definitely enlarge as large as possible, move the color bar here maybe and make it as large as possible. So this would be, to my opinion, this is unnecessary space, and this is also unnecessary space. I will make sure that it's fully occupied, okay? And also during your talk, you talk fluently, that was really nice, but you were most of the time looking at your screen. It would be great that next time you can look at them. And it's probably also so natural for you that, okay, you means what? Okay, but this is not the case for people who don't study physical oceanography, not even professors, because some professor will ask, oh, what does you mean? What does positive value or negative values mean? So it will be always good to say, this means east world, this means west world. Okay. Okay. And this actually was confusing to me because you were talking about intraseasonal migration, but then your conclusion was about seasonal pattern. So is this seasonal or intraseasonal? Okay.
It's seasonal, but it is interesting.
This conclusion was a little bit not so, because the keywords was not intuitive, 直觉的. Therefore, it was really confusing. Okay, what does the sentence really mean? Okay, so if this is the sentence from the paper, maybe you can use your own words, convert it to plain language. What does it really mean? Because this is not too very clear to me, this sentence. And it's really nice that you add this curve, so because the quality of the figure is bad. And then you were saying like what happened when it moved eastward, what kind of salinity or temperature. Maybe you can use some guideline to give example. For example, like you are talking about this or this, then what kind of temperature or salinity you are talking about. Okay, and 14 also at guidelines. Yeah, and this here now it's there is relatively much text, have a lot of text. So when you have slides like this, first you color code your keywords because it's too much. So I simply stop reading. Okay, and then if you are talking about the first point, maybe you can add a guideline to show us, okay, what is the feature you are talking about, and second, and the third, and the same for this one. Then it will be clearer to us that you are talking about this feature or that feature. Okay, overall, it's a very nice talk, but there's still space for improvement. I hope to see you improvement next time. Okay, so thank you, Stephanie.